join namusi. Rune namusi.
Okay.
Record to my image chapter in the chapter 3.
Yeah.
So this chapter is about vectors. So we must know everything about the vectors. So the very first question we may need to answer here, Nuri Richie vector mean. So
Okay.
now, what is a vector?
A vector. Raru naita before.
No, but it's done from secondary. Scalar quantity and vector quantity. You remember those things?
The vector. Madly filigo liumbura mara.
Yeah, vector. Is a measure that have magnitude and direction. And a scalar is a measure that only have a magnitude. It does not have what? It does not have direction. Okay. So then now, there's a relationship between vectors and matrix. Last time we recorded as matrix, so now recorded as vector. So vector is given in this form. So it's a certain variable with a head or an arrow on top, which this arrow indicates that it's a unit with magnitude and direction, of which is represented in components. Let's say the components here are U1, U2, U3, up to UN. So that is a vector. So vector U, it must have components, of which we can write as an example, e.g., we can have U 1, 2, 3. So it means this is a vector in how many dimensions? In 3 dimensions. So it's in X dimension, Y dimension, and Z dimension. So in this is in this formation. Here we have X, and then we have Y, and then we have Z. So then for X, let's plot this vector on this Cartesian plane. We are no longer dealing with 2D in this case. We are dealing with 3D. So the dimension for that vector is going to be 1 for X. So let's say 1 for X is here, and 2 for Y, let's say is there, and then 3 for Z, let's say is there. Therefore, where they intersect is where we're going to have, a point of this vector U. So it have direction, and it also have a magnitude. You can be able to tell the magnitude of that vector. Raw terms. Nah. Volume yabo ipasinyana. I don't know. Urezika side yana. Yeah, ngamanda like ndikoto gezo ri vadawa kambori me.
Zino ma zino vakompa.
Ikati khaira kuti voita nganthu ngaidzi.
Zino vakompa.
Yeah, zwi khwine nyana mara vakadipfela kule nyana. Mara it's okay. Vakuita headphone.
Dandu connect na guru.
Oh, okay.
Okay, fine. Haven't connect through.
Vakumfa zino?
Yeah, ngamanda. Ndiko vapfa zvino.
Ngamanda ne?
A.
Okay. Oruk.
So ndo ṱalutshedza uri vector ndi mini. So vector ri vha ri khou amba nga a measure which have magnitude and which also have a direction. And I've given an example of the vector in this case. So now, one of the things we can encounter is for us to be able to add two vectors. So let's say we're in a vector here you and then 1, 2, 3. Ravana vector ya v ine yava 2, 9, 1, and we are required to add these two vectors. So the addition of vector u and vector v, when we add them together, we just add them components wise. So it means first component we add it together with first component. Second component we add it together with second component. Third component we add it together with third component, of which is going to be 1 plus 2, which is 3, and 2 plus 9, which is 11, and 3 plus 1, which is what? Which is 4. So that is how we add what? Add the vectors. Rewrote them.
Oh, Zambori. Ridzi eda ungari riko eda matrices.
A. Ridzi eda richinga riko eda matrices.
Okay.
Yeah. So that is the introduction about the vectors. Now I'm going to the critical thing which involves the vectors. So that is what is called the norms. So norms of vectors. So we have three different norms. All right. Sajenda Jiamba Ndori vector the measure.
A.
For example, if you go to the Uambori, weight ya a calculator, and you guys, remember you are going to give certain number to tell the weight of this calculator. So vector is a measure. So now, because a vector is given in terms of different number, let's say 1, 2, 3. So if you have something like that, you cannot be able to tell the weight of this vector. You cannot say the weight of that vector is 2, the weight of that vector is 3, the weight of that vector is 4. It's 3 in that case. So, but there's something which you need to do in order for you to have exact value for measuring this vector. What you're supposed to do is to involve what is called the norms. So, Jambori norms is measure size ya vector. So, Jine rina normal tables are different. So the very first norm which we must know is what is called the one norm. So one norm is indicated by something like that. So let's say we have a vector like this. So you're gonna be able to measure how long is this vector from here to there, of which you use the norms to measure that. You no longer use the distance formula. Distance formula, it no longer applies when you have something like that. If you want to measure, you are not going to say root of 1 squared plus 2 squared plus 3 squared. No, you need to use the norms now. So the distance formula is you have to use the absolutes like this. But now the norms, you can see we use double strips here. So it's called the norm. It's the measure. It can tell you the distance from here to there, of which there are certain formulas which I'm going to introduce to you. But now, I focus the norms. Normal term is one norm, and the normal will read 2 norm. It's a 2 norm. And then the last one is what is called the infinity norm. We also have Frobenius, but I noticed during you don't do Frobenius. But in this case, let's focus on the 3, which is 1 norm, 2 norm, and infinity norm. So the question is, how do you calculate? How do you calculate these norms? How do you calculate these norms? And it's what I'm going to do with you just now. So these are the formulas for calculating a norm of vectors. At later stage, we're gonna do norms for matrices, but now we're doing norms for vectors. So the very first one there is norm 1. In a norm 1, in our formula, you read infinity I from 1 to n of absolute of xi. Xi means the components x1, x2. Let's say we have a vector x. So a vector x, it has components x1, x2, x3 up to xn. So all these vectors of x1, x2, x3 up to xn, they are indicated by this which we have here. Of which for norm 1, you can get it by getting the absolute of this, and then after getting the absolute, you get the sum. The example was one of the Richiwana norm 1 resistance. All right, that is the first one. And then we go to the second one, which is called the 2 norm. How do we calculate the 2 norm? So the 2 norm, we calculate by the infinity again. So we're going to have root of infinity from I from 1 to n of xi squared. These are more or less the same. These are more or less the same. Is that in this case, we have a root of sum of xi squared. Instead of just taking the sum of absolute of xi, you are now taking the square of this, you sum them, and then you take the root. You'll get what is called the 2 norm. Then now let's finish up with the infinity norm. So the infinity norm is given by maximum. In this case, you are going to take the maximum from the values that are given. So you take the maximum of the i's, of the xi's, absolute of xi's. And with that, you will have the infinity norm. This is important in a month. I can tell you without any hesitation. These are very, very important quantities because instead of measure a vector, are going to measure a component consider components occasion. So you can choose how to measure. You can measure by 1 norm, you can measure by 2 norm, you can also measure by what? By 3 norms. Sometimes question is not specific. Or measure 1 norm, and measure 2 norm, and measure 3 norm. But if you are specific, you need to choose how you measure at the vector. You measure the vector from these 3 norms that we have. Read the example.
Yeah, that example bando.
All right. So go to the
The one ngandone. Zvidova zviko pfala sachatori kuita example.
yeah. Go to the
Zvitova zvisvo.
yeah, man. Go to example in another negative. With I mean in this case. So in a vector u in about 1, 0, -2. And we're supposed to take 1 norm. We'll start with 1 norm of this. 1 norm of that vector u. So it means we're going to have 1 norm of u is equal to. So we are going to take the absolute of each component that we have here. What is the absolute of 1? Absolute is like, I don't know if you are aware of this. So absolute of -1 is going to be +1. Absolute of -2 is going to be 2. In other words, the absolutes, they change the negative values to be the positive values.
Okay.
Yeah. Yeah. So absolute of 1, which is going to be 1. Absolute of 0 is going to be 0. But now absolute of -2, what are we going to have for absolute of -2? We're going to have a 2 because absolute changes -2 to positive. So after having this, we then now have to take the sum of this. we take absolutes of each component, and then after taking the absolute of each component, we then take the sum. So sum is the absolute zviamba zvarequire 1 plus 0 plus 2, of which the answer is what? Is 3. And that is how you arrive to the answer. Therefore, if you are picked, what is the measure of this norm here? By using one norm, you are going to say it's 3, of which you get by using this formula that we have there. Rotham's vozvona uri rosvikisani phindulo ya one norm. Hello? Hello? Vadimfa.
Lebundo?
Yeah. Network yetu angeke techibaizi.
As network, what do you mean? iPhone enda kushuta yani. Yombo dipela petritso. Yenda hotspot ngayo yambo ditsima, nambo dimbisa ndomanga nditsiwa ka network.
Oh, okay.
Mm.
Mara zvazvino right angado
Zangu
kata na battery.
ndoi kita nga USB cable na goroi. Towari TV ndovura hotspot ingakora mara asarpte. Udita tara rianga katai. When about these upon the lesson, the retrace.
Okay. So ndaga
Mara iya
ditarushedza.
ditakadzabona mu.
Yeah, exactly. Ndaga ditarushedza uri wanisani one norm. One norm ndiyo ine ravanayo pano. So ritoma ngodarajia rikotavira ngei formula ine pano. Rikodanga tuma kujia absolute value ya idzi components dzote dzine dzava pangango. So absolute ya 1 and 1, absolute ya 0 and 0, absolute ya -2 imbo dzichinja yava yava 2 ngori absolute ichinja dzi negative values dzava mini dzava positive. Ndizvo. All right. So after runowana dzi values dzine dzava dzi absolute, rikodharajia sum ya on k sum apano rikodharajia sum there 1 plus 0 plus 2 yarekusera phindulo ya 3. So zviamba zvari hei ndi phindulo ya one norm of vector u. So can we also do two norm for that vector u?
Two norm.
This one.
Okay.
All right. Two normal. This is how we take the two norm of that vector u. So we're going to square. We now have to square the values we obtained here. So it's xi squared. So what is 1 squared? It's 1, right?
It's 1.
And what is 0 squared? It's gonna be 0. Negative 2 squared is gonna be
4.
what? It's gonna be 4, right?
Yeah.
So after squaring, we then take the sum. So the sum, it means we're going to add all these. And then after add, we have the root. So it will be root of the sum of this, which is going to be sum of 1 plus 0 plus 4, which is the same as the root of 5. So therefore, norm 2 of this is going to be root 5.
Okay.
Yes, norm 2 of that vector is going to be root 5. And you will see that they're going to be very close to each other, these values. They're going to be very close to each other because this is just a measure. You just choose a measure that you prefer. All right, then let's go to the last one, which is the infinity norm. So the infinity norm, this is how you get the infinity norm. You will have to get the absolute. It's more or less the same with the first one. You get the absolute of 1, you will have 1. Absolute of 0, you have 0. Absolute of negative 2, you're going to get what? You're going to get it 2. And then after getting that, you choose the one which is the highest, the maximum value. So which one is the maximum between the three there?
The last one.
Is the last one, of which is 2. So therefore, we now have the answers for 1 norm, the answer for 2 norm, and the answer for infinity norm. Very, very interesting.
Oh, that. Jambo, Bondo.
Nah.
Zvibari kupanga ka okay. First norm jambo equal the sum of nomboro dzote dzila.
Rotomara dzichenesa ka the absolutes.
Okay. Oh, ndi kuformula okukuformula kwa kuri wisela zvezvo kuri kumwala kwa first norm kuri this n sum of I equals to 1.
Yeah, exactly.
Oh.
There's formula za norm. Formula ya 1 norm ndiyo iraiteweza kuwa na hekidro hii hapa.
Bondo bado kama ndite mini? Kama mpe 2 minutes ifoni iko yo ingasiri tende aba mpe 2 minutes ndijene ka bank app ndirenge airtime ndirenge data nga yanga ter.
Okay, auna kakati. Okay.
Ndaji 100 gig ingar pushat 100 megabyte ingar.
Yeah. Data 100 megabytes.
Okay. Apendi kondi kuchekela phone yo sana nga iko tsitsa iko gonyisa nangondo itoma ka phone ayiko tenda.
Oh, ish.
Okay. Yeah, Ftonga was right.
Okay.
Okay. Are pan.
All right. So our individual example, yeah, this is normal dot. Before the check dot product na cross product. Let's say we now
Ufuna
have
bachinga badzimweleke Vondo.
that.
Kabadzimweleke chanda changa apa va drone ku graph ko ange nta ayekuvona na zvavo.
Or the draw up on
Ava mwalenga nepo ngange akuvona dzange nta. Ava mwalenga nepo.
Okay. So this is our second example. So let's say we have this vector u given by -7, 10, 2, 12. So it doesn't matter how many components we have here. So now let's check one norm. Let's check one norm for this. So one norm for that, we're going to get it by having an absolute of 7. What is absolute of 7? Is 7. Absolute of 10
10.
is 10. And then absolute for 2, let me get this other marker. Absolute for 2 is gonna be 2. And then absolute for 12 is gonna be 12. So after having all this, we have to add all of them. We're gonna have 7 plus 10 plus 2 plus 12, of which this will be 24 or 31. So norm 1 of u is gonna be 31. So let's do norm 2. So how are we gonna get norm 2? We will have to square these values first. The square of -7 is gonna be 49. The square of 10 is gonna be 100. Square of 2 is gonna be 4. Square of 12 is 144. And then from there, we can have norm 2, which will be given by root of the summation of these values. So root 49 plus 100 plus 4 plus 144. So the answer for this is going to be root of 49 plus 100 plus 4 plus 144. So we're going to get 17.23. And that is 2 norm of this vector. So now, after having 2 norm, we can then have infinity norm. We don't have 3 norm, we don't have 4 norm. The last one is 2 norm. And then after having 2 norm, we have infinity norm. And then after infinity norm, we have Frobenius norm, which we are not covering in this case. So the infinity norm is going to be given by the absolutes of this, the maximum absolutes. So absolute of 7 is 7, absolute of 10 is 10, of 2 is 2, of 12 is 12. And then we take the maximum. Which one is the maximum there? Which one is the highest from those ones we have there?
Vondo.
Nah.
Nditwala hafu. Vadoneta mini ndandomouta ndisingozvivona. Ndikusokuamba ndindote.
Oh, okay. Ndikubonga yeta yofera chipinga. Ndikubona ibvisa chipinga apa ndiri. Ndikuamba ndote yofera chipinga. So zvambada ikova 12 ti?
Yeah.
Yeah, I believe with the masters, known
or the norms of what?
of
Norms
vectors.
of vectors.
Yeah, at later stage, require the norms that the matrices.
Okay. That's the vector chimsa zvezvi.
That's the vectors zvishumiswa this. Adzichinji nakuti if you are could do
Now that the line the line dzinji dzisvika 10 dzichangorari.
yeah, whatever the same procedure.
Oh,
Yeah.
okay. Whatever is formula. Every formula zviadhadhisa mari wasasedza formula waritanga endeni kufuta ngayo zvinova simple zvika zviformula pana vsquare root zviadhadhisa ya.
Yeah, exactly. I believe that this must arise. This is very important, Ngamanda.
Okay.
What this is second year, third year, or from second year up to PhD. These don't change the norm. The normal they replace a distance formula. Yeah, the norm
Okay.
just replace a distance formula.
Mara why ava vatu vainvesti curriculum yavo isa amendiwi ndikofunza mini vana vagrade 12 zvitu ngori hazviyo kavo. What's the purpose yori vatraine nezvitu zvine grade 12 ndikokudzifunzira vana calculus.
The syllabus ya secondary I aligned na university. And zvitu zvinosvikotechinja ndizva secondary ndo secondary hukoitwa zvinhu zvisaexist hazvisolve problems real life. So hezvi zvine kwamba zvone apa ndizvo zvine zvashumiswa kusolve problems real life. So zitita ndikotarisha but this which you are doing here ndizvo zvine ravari kwambori zviapplywa kuresolve problems dzine exist in real life situation.
Okay.
All right. So Jambori, Areka, last two part which I want to, I think we still have some time because I want to cover two important topics for norms. For vectors. What if I cover it? I think we the Rosh issue Mamshumadu. So the first one which I want to cover is what is called the dot product. So the dot product of norms. We must be able to find the dot product of norms. So dot product, we are referring to the dot in between the vectors like this. So u dot v, we must be able to calculate that. What is u dot v? That is not just a normal multiplication. At secondary level, we say this is normal multiplication, where 2 times 3 is the same as 2.3. Yes, that exists. I don't know if it's common this at secondary level is the same. You're gonna get the same answer of 6. But at university level, it's not the same. 2 times 3 is not the same as 2.3. It's two different things. So now I'm going to cover those two things for you. So this one is called dot. So it's 2.3, and this one is cross product, is 2 cross product 3. So, but now we apply that in terms of vectors. So we apply the dot product and the cross product as a vector. Rune, let's say we have two vectors on 3 space. So let's say we have u1, u2, u3. You can go beyond that. It's not restricted to 3 components. You can go beyond 3 components. And then the same with v. Let's say v is given as v1, v2, and then v3. So the question is, how can you find the dot product of these two? And this is how you find the dot product of these two. So you're going to have u1, u2, u3, dot v1, v2, and v3. So the dot product of this is going to be given by you multiply this component with that component, you add, you multiply this component with that component, you add, you multiply this component with that component. So it means you're going to get U1 U1 V1 plus U2 V2 plus U3 V3, and that is how you are going to get the what? The dot product of two vectors. Rewrote terms.
Yeah.
Yeah, at later stage, I'm going to tell you what this means, because they tell you about the relation between the two vectors. If the vectors are perpendicular to each other, if the vectors are parallel to each other, such kind of things, they are coming from this dot product and the cross product. So that is all about the dot product, of which now I can give you an example, and then we quickly go to the cross product.
Ravundo.
Uh,
Hey, yeah. What there is a message during 15 megabytes left, hey?
as memory equal megabytes in.
So abapedzisa ile sanity
Yeah.
zvevava kunyangozvikavhara ila foni ichiboosta ndidzo dzindidzeipedzisa ngana kutenga taidzo ndori vansendera kayoutube iyi todzo ndikoretrieva mara kana kuti amara zviyafana oruga zviyafana ndideitovera kaya kabadonsendera kagroup kayoutube ndideitovera.
Okay. Ava ndinambe nditaluchidze cross product maybe vasatotu. In a cross product, riva rikwamba instead ya dot riva rinova na cross. Mara cross product, we do it in this way. We are going to have a determinant like this, where the first row is going to be given by I, J, and K. So these are the direction. This is the direction on X, and this is the direction on Y, and that is the direction on X. So on the second row, we're going to put U1, U2, and U3. And then on the last one, we're going to have V1, V2, and then V3, of which this we can use the determinant to find that, and we hold the first edge, I. In that case, when you hold the I, you will now have U2, U3, V2, V3, and then minus J, and then here we are going to have U1, U3, V1, V3 plus K, and then the last one is going to be U1, U2, and V1, V2. So that is how we find the cross product of U and V, of which this, I believe you know how we're supposed to do that. We have done in the previous lessons. You cross multiply this with that, it's going to give you U2 V3 minus U3 V2 minus J, and then here you have U1 V3 minus U3 V1, and then on the other side we have U1 V2 minus U2 V1, and that is how we're supposed to find the cross product of this. All right, let me quickly do an example so that you see how we attend to the example of these questions. So U, which is given by, I'm going to give an example of 1, 0, -2, and V, which is 2, -1, 0. So how do we find the dot product of this? U dot V is going to be given by 1, 0, -2, dot 2,